Hello again! In this video, I'm going to do a short tutorial about EvoLogics networking features as a part of EviNS framework. What is EviNS? EviNS framework is an open source project. The framework is running on Erlang virtual machine and comprises a set of independently running agents. Each agent is defined in the form of finite state machine and is driven by externally generated events. Each agent is fault isolated. If so-called worker process crashes, it is restarted by a supervisor process without affecting others. This model makes EviNS framework very stable, and this is exactly what we need in the underwater communication tasks. How can I get EviNS? You can download it from GitHub. You should see a link on the screen right now. And now you should see the link to EviNS wiki with information and some useful implementation examples. We are going to GitHub now. What we see here are the EviNS directories. Include directory with some macros which define the structure of finite state machine, source directory, and the example directory, which can be used as a template for quick start of EviNS. So now we are going to install the framework. I'm going to clone it from GitHub. So I copy the link and open terminal. Go to the directory you want, in my case I have work GitHub directory, and type git clone. Now we have to compile EviNS. This is simple, run make. So it is downloading all necessary dependencies from GitHub, for example, Cowboy and other libraries. Now EviNS is successfully compiled and ready to be configured and run. We'll continue with EviNS configuration later. First, I'd like to do a short overview and talk about the network protocols implemented in EviNS. To understand the connections between different software parts, here's the OC model once again. In the past videos, I told about the physical layer and the data link layer. Now we are switching to higher levels, MAC and the network layer. You will later see how both layers are implemented in EviNS. What is MAC layer and what is it responsible for? The MAC protocol that we spoke about in the previous videos provides media access control for burst data transmission. It allows for so-called backoff state, when a modem does not start transmitting data during an ongoing transmission between others. With EviNS, we implemented several different media access protocols for modem networks. These networking protocols control transmission of instant messages that DMAC has no control of. In a network, each modem can relay data to other modems. It can very often occur that several modems will try to transmit data simultaneously. That's why the existence of an extra MAC layer is necessary, as it helps to avoid collisions. It determines and controls who is allowed to access the transmission media. We used EviNS to implement several well-known MAC protocols such as CSMA-LoHi and TON-LoHi protocols. Now let us look at the network layer and routing protocols implemented in EviNS. All routing protocols we implemented are flooding-based protocols. We can divide them into three types, depending on a task has to be solved. The first type is relay, flooding the network till the destination is found. This protocol needs a lot energy of network, but is pretty dynamic and robust. It can be a great solution for a network with mobile nodes. The second type is pathfinding and relay. The difference is that it starts with pathfinding from source to destination, and then the data is delivered through this path. This type of routing is more energy efficient than relay, but it is better suitable for more or less static network topologies. In a network with fast-moving nodes, this protocol type is too slow to detect the path loss. The last type of flooding-based protocols we called polling. In this algorithm, there is a master node. The master node sends requests to other nodes on the network and asks if there is data to be delivered. Every node is allowed to respond only when it is its turn. This method enables time division between network nodes, and in this way it avoids collisions during data transmissions. And finally, here's the practical part. I am going to use our DMAs emulator with 7 emulated nodes. To visualize, I will open our Synapse positioning software. I already configured it to display the network topology I will use in our examples. Here we see the 7 modems in the network Modem 1 and modem 7 cannot communicate directly because the distance is more than 2000 meters. A routing protocol has to be used to deliver data from modem 1 to modem 7. This will be our goal in the following example. The simplest routing is static routing. This protocol belongs to the relay type. To use this type of routing, we need to have information about the network and its links. In our case, to deliver data from modem 1 to modem 7, we need first send data to modem 2, modem 2 to modem 6, and modem 6 deliver data to destination 7. This is the path we are going to configure in EviNS. The simplest way is to modify an existing configuration example. I already found it on GitHub, wiki page of EviNS, under network layer compile run examples. Look at the example for EviNS configuration file for static routing. According to the wiki, we need to create an FSM configuration file and place it to corresponding directory. This configuration file describes which modules are going to run EviNS. In the wiki example, we see the config file contains two modules. The first module configures the MAC protocol. In this case, we will use CSMA Aloha. This is okay for our task. In the second module, we configure a network layer. In this case, we will use static routing. So, okay, we have to copy the configuration file, go to the EviNS etc directory, and place it into an empty FSM config file. Now I will adjust this configuration for our needs. First, I'll change the IP address of the modem to the correct one, 10.42.0.1. MAC protocol is CSMA Aloha. We keep this. Local address of the modem is 1. This is also correct. And the default routing is 2. It means that everything modem 1 transmits will be by default sent to modem with network address. It works for our scenario. Now we need to extend this config file with configuration for modem 2. So I copy the configuration of modem 1 and make adjustments for the modem 2. So first, I change the IP address to the IP of the modem 2, and to run EviNS locally on PC for multiple modems, we will use loopback network interface for each modem. Local address 2, and we set the routing. Here it should be like this. If we have data for modem 1, send it to 1. In all other cases, send the data to modem with network address 6. So I did the same for other 5 modems. Here's the final configuration file. To run EviNS, type rel EviNS bin EviNS console. So it started now. To simplify networking with EviNS, we developed NL commands, the network layer commands. NL command set runs on top of the AT commands and provides network-specific functions. There are commands to send and receive data, commands for network configuration, commands to start and stop processes, as well as some commands for statistics. Let us use an NL command to send data. I'm looking to its format in wiki. I'm going to send data link. Here is the format, NL send. Entering length is optional. It will be calculated automatically. And now I open my terminal. On the left side is modem 1. On the right side, modem 7. I also have Synapse open to visualize the signal transmission in the network. I'm now sending data to modem 7. See, data is first delivered to modem 2, modem 2 transmitted to modem 6, and then to modem 7. There we go, we received data on the remote side. Now let us use another network protocol, for example, flooding protocol. In this case, we do not need information about network topology. The whole network will be flooded with the message until it reaches the destination node. Let us now reconfigure EviNS. What we change here is the name of protocol for each modem. It is now SNC floodr for flooding. And delete routing because we do not need it anymore. So I made the changes for all 7 modems. Let us restart EviNS. Now I open the terminal and connect to modem 1 on the left side and modem 7 on the right. I will use an NL command to check the current networking protocol. So correct, it should be flooding, and now I'm sending data to modem 7 in the same format. Look at Synapse visualization. There are no errors for unicast message transmissions that we saw in static routing. Now everyone in the network tries to retransmit the message by broadcasting. It's like an avalanche. We can request each modem for its neighbors. These are network nodes the modem can hear. Let us do it. So in case of modem 1, the neighbors are 2 and 3. See the same in Synapse. And modem 7 has neighbors 6 and 5. See it in Synapse. Let us try out a pathfinding protocol. Let us now reconfigure EviNS. Here is the final FSM conf file for all 7 modems. The protocol name is now EvoICRP Pathfinder. Now let us start EviNS and connect to modem 1 and modem 7 as we did before. I will use an NL command, request the current routing setting. So current default routing setting is to broadcast. The route will be found afterwards. It means that if we try to transmit data now, the protocol will first perform the path establishment process, and afterwards it will deliver all the data to destination node using these paths. So I'm now sending data to modem 7 in the same format as before. We see NL send response. It means that message was accepted for execution. And NL path establishment process began. Let us look at this process to Synapse. First, we saw the broadcast for pathfinding. And now we received our routing response. This means the routing table for modem 1 was filled out. Let us take a look. So the routing is now modem 1 transmits data to 2, modem 2 to modem 5, and then it delivers to modem 7. So let us take a look. See, here's the routing found for modem 1. I will also check the paths now. So we see here 7, 5, 2, 1. Look at Synapse once more. We will transmit data, high 7. Data is now being delivered over that path was found. So we see here on the other side that modem 7 got the data and modem 1 got delivered acknowledgement back. So last but not least, I wanted to show you the useful feature of requesting transmission stats. With an NL command, statistic of last transmitted data can be requested. So you see NL get statistics data command. You can see its hash, the length, its delivery status, duration, source, destination, and hops. I hope this video was useful for you. Thank you and see you in the next video.